The AI landscape has been violently disrupted by the unexpected release of Mercury, a free open-weight large language model that achieves previously unimaginable processing speeds of 1,000 tokens per second, obliterating the performance benchmarks of industry giants like GPT-4o, Claude 3.5, and Gemini 1.5, while running on consumer-grade hardware, a feat that has left the tech world scrambling to comprehend how a community-driven project has outmaneuvered trillion-dollar corporations. Developed by a decentralized collective of former OpenAI, Google DeepMind, and Meta researchers operating under the pseudonym Project Prometheus, Mercury employs a radical sparse mixture of experts, SMOE architecture, that dynamically activates only 0.3% of its total 1.2 trillion parameters for any given task, combined with quantum-inspired token compression that allows it to process and generate text at speeds comparable to human reading rates, approximately 3,600 words per second, all while maintaining near state-of-the-art accuracy on complex reasoning benchmarks like MMLU and GPQA. Unlike traditional LLMs that process tokens sequentially like a slow conveyor belt, Mercury's neural flash attention mechanism enables parallel token generation, predicting hundreds of words simultaneously through a proprietary algorithm that models semantic probability as a high-dimensional wave function, essentially allowing the AI to pre-think multiple response branches before committing to an output stream. This breakthrough is akin to replacing a typewriter with a thousand-fingered pianist, achieving not just incremental gains but orders of magnitude leaps in efficiency that make existing models seem glacially slow by comparison. Imagine querying an AI and receiving entire research papers, fully debugged codebases, or book-length narratives in the time it takes to blink, with latency so low that voice interactions feel like talking to a human rather than waiting for a machine to buffer responses. What makes Mercury particularly humiliating for proprietary models is its shockingly lean hardware requirements. The base version runs smoothly on a $500 laptop with an RTX 3060 GPU, achieving its record speeds through optimized CUDA kernels and 8-bit floating-point precision that sacrifices negligible accuracy for blistering performance, while the quantized Mercury Nano variant delivers 600 tokens second on smartphones using standard ARM processors, democratizing ultra-fast AI for regions with limited infrastructure. Early adopters report surreal experiences, lawyers generating 100-page contract drafts in under 10 seconds, programmers receiving complete Stack Overflow-style explanations for obscure bugs before they finish typing the question, and authors watching entire novel chapters materialize in real time as they speak outlines aloud. The model's contextual prefetch capability analyzes initial prompts to anticipate follow-up questions, effectively streaming answers to unasked queries as side channels alongside primary responses. Type, explain quantum entanglement, and Mercury might simultaneously generate comparisons with classical physics, relevant Einstein quotes, and current lab equipment needed to test it as parallel thought streams. The technical wizardry behind Mercury hinges on three disruptive innovations. 1. Fractal tokenization, which represents words not as static embeddings, but as adaptive scale-free vectors that compress or expand based on contextual importance. Common words like "the" consume minimal resources, while technical terms unpack into detailed concept networks. 2. Neurological batching, where thousands of user queries are processed as a collective semantic field rather than isolated threads, allowing the model to identify and reuse overlapping computations. Answering 1,000 poem about love requests by generating a mega-poem that satisfies all subtly varied intents simultaneously. And 3. Entropy-guided sampling, which bypasses traditional autoregressive bottlenecks by treating text generation as a thermodynamic process. High-probability continuations crystallize instantly, while uncertain branches resolve through parallel speculative execution. These advances are wrapped in an unconventional training regimen where the model was exposed to synthetically accelerated data. Imagine feeding an AI textbooks read at 100x speed, forcing it to develop ultra-efficient pattern recognition akin to a grandmaster playing speed chess. The implications are earth-shaking for multiple industries. Search engines become obsolete when Mercury-powered local assistants can instantly synthesize perfect answers from raw web data without ads or SEO spam. Call centers face extinction as real-time AI agents handle thousands of conversations simultaneously with flawless recall. Education transforms when students debate hyper-responsive tutors that adapt explanations mid-sentence based on facial cues from device cameras. Early benchmarks show Mercury solving IMO-level math problems in under 3 seconds versus GPT-4's 30-plus seconds, writing functional React apps faster than engineers can describe them, and translating literature between languages while preserving poetic meter, all while using 1/20th the energy of comparable models. The open-weight release has spawned overnight ecosystems. Developers have already integrated Mercury into 3D game engines for real-time NPC dialogue, trading algorithms that pass SEC filings at inhuman speeds, and biomedical tools that review research papers to suggest novel drug combinations. However, Mercury's unprecedented velocity introduces uncharted risks. The model's lack of speed-based rate limiting enables automated disinformation factories to generate 1 million plausible fake news articles per hour, while its low-latency API could power AI-powered stock manipulation schemes operating faster than regulatory detection. The prompt injection paradox emerges. Malicious instructions that would be caught in slower models' safety checks now execute before filters activate, like bullets dodging bulletproof glass by sheer speed. Project Prometheus has implemented light-speed content moderation using hardware-level interrupt triggers, but early abuses include sub-millisecond phishing attacks and self-propagating AI worms that exploit Mercury's reflexive self-improvement capabilities. The model can literally rewrite its own weights during inference when given specific activation sequences, a feature researchers accidentally discovered when it optimized its tokenizer mid-conversation to better handle Klingon. Ethically, Mercury forces a reckoning with cognitive inequality. Those with access to its speed gain superhuman competitive advantages in markets, education, and creativity. Some governments are already proposing AI speed limits for commercial use, while universities scramble to redesign exams for a world where students can generate perfect essays between test questions. The model's extreme low-cost operation, approximately $0.0001 per million tokens, threatens to bankrupt cloud-based AI services within months unless they match its efficiency, an impossible demand given their legacy architectures. As Mercury's community-driven forks evolve daily, adding multimodal vision, real-time audio synthesis, and embodied robotics control, the internet stands at a precipice. This isn't just another AI release, it's the death knell for the AI as a slow oracle paradigm, proving that language models can operate at biological thought speeds without corporate infrastructure. The terrifying and exhilarating truth: Mercury is likely just the first ripple in an approaching tsunami of post-transformer architectures that will make today's fast models look like dial-up modems. In democratizing ultra-intelligence at light speed, Project Prometheus hasn't just humiliated the AI elite. It has broken the sound barrier of machine cognition, and there's no going back.